Welcome to EDU World Space.
So to answer this question, we must use the conservation of energy law. So we can set that the kinetic energy is equal to Coulomb's law in this case. So 1/2 over here, let's do the expressions in blue. So 1/2 mv squared is equal to Coulomb's law, which is kq, Coulomb's constant, times charge 1 and charge 2 over the radius. And since we're given all these constants, we just need to plug it in and solve for velocity. So 1/2. So let's actually first let's isolate for the variable v. I think that would be easier for all of us. So if you do v squared is equal to 2kq times the second charge over the radius times its mass. So that's an r. Sorry, let me just make sure. You can differentiate between the r and the v times its mass. So if you plug in all the values, so 2 times 9 times 10 to the power, sorry, what's Coulomb's? 10 to the power 9, yep, times the first charge, which is 3 micro, which is 3 micro coulombs times 3. Sorry, it's actually, the first charge is actually 5. I mean, it doesn't really matter which one which charge we take first, but I just like to keep it in order of the question. So times -9, since it's microcoulombs, and micro is to the power of -9, 10 to the power of -9, times the second charge, which is positive 3 microcoulombs. So times 3 times 10 to the power of -9, all over the radius, which is 8 centimeters. Yep, so which is 0.008 meters. And times the mass, which is just 6 times 10 to the -5. Yep, kgs. So 6 times. So these are all just constants. So I'm just referring back to the question to find out these constants. 6 times 10 to the -5 kgs. It's important that we have all these in standard units. So velocity squared. So now we just can compute this and actually just take the square root of this, since we need to just square root both sides. Yep, hold on. Let me get all of this so I can do a proper square root sign. Yep. The radius is here. So now all we need to do is just square root both sides, since it's velocity squared. So if you square root both sides, we're going to get the answer. If you just plug this into our calculator, we're going to find out that the velocity is equal to 150 meters per second. And that's it for this one.